Okay, today we're going to work on compound and continuous interest problems. There will be word problems, so I'm hoping this isn't too blurry, so we'll see how this goes. So compound interest is this formula, and the formula is, in case you can't see it, A equals P times 1 plus R over N to the NT. And that's the formula we're going to use for this. So A is the balance. So A is always how much money you want to end up with. It's the ending amount. Okay? P is the principal. The principal is the initial deposit. How much did you start with? R is the annual interest rate expressed as a decimal. So you always have to, in the problems, it'll always be a percentage, and you want to turn it into a decimal. So that's your R. Your N is the number of times the interest is compounded per year. Now that's going to use some different words here. So you will see compounded maybe yearly. That means 1, because compounded yearly means 1 time a year. Compounded semi-annually means 2, because annually is the same thing as yearly. I ran out of room. So annually and yearly mean 1, and then semi-annually means 2. Okay? Then you're going to see quarterly. Quarterly means 4 times a year. It's compounded 4 times a year. Okay? Then you'll see monthly. Monthly means 12 times a year. Okay? Because there's 12 months in a year. Then you may see weekly. And that means 52 times a year, because there's 52 weeks in a year. You may see daily. Daily means 365. We don't worry about leap years. We just count it as 365. It's 365 days in a year except for leap year, but we're just going to count 365. And those are the main ones that you will see. So those are important to know what they mean. Okay? Okay, so here's our first problem, and it says, how long should $5,000 stay in a bank account that pays 6% compounded monthly to yield $8,000? So if we look at this, we're going to say we want to use the formula A equals P times 1 plus R over N to the NT. So we need to know our A, our P, our R, our N, and our T. Okay? So A is the amount that you want to end up with. Well, it says yield 8,000. That means that's how much you want to end up with. So A is 8,000. P is your principal. That's the amount you start with. So we put 5,000 in the bank. So P is 5,000. R is your rate. Your rate's always your percentage. So that's 6%, but we want to convert it to a decimal. So you move your decimal 2 places. So that's 0.06. N is the number of times it's compounded per year. And this says compounded monthly. And remember, monthly was 12 because there's 12 months in a year. And then T is the time it takes. But if you notice, it's asking how long. So that's what it's asking for. We need to find T. So what we're going to do is we're going to plug this into our formula. So A is 8,000 equals P, which is 5,000, times 1 plus R, which is 0.06, over N, which is 12, to the N, which is 12, times T, which we don't know. So we're just going to put a T. Okay, so we want to solve this. So it's solving just like we solved the others. If you notice, the T is in the exponent here. So we want to isolate this exponent. So we're going to divide by 5,000. Those cancel. And 8,000 divided by 5,000 is 8/5 equals 1 plus 0.06 over 12 to the 12T. Now, everything in here, there's no letters. It's all numbers. So what we're going to do is we're going to go ahead and type that in our calculator. So we're going to get 1 plus 0.06 divided by 12 And that's going to give us, we have 8/5 equals 1.005, and that's exact, to the 12t. Okay? Now remember, in order to get something out of the exponent, we got to get rid of this base. So what we're going to do is we are going to take log base of using this base. So we're going to say log base 1.005 of everything. These are going to cancel, so this is just 12t on this side. And this is log base 1.005 of 8/5. And that's not going to be a nice pretty number, so I'm just going to leave it. And I want to solve for t, so I divide by 12. So I'm going to type that whole thing in my calculator. So I'm going to type in math, go up to log base, and base is 1.005. And then inside of it, we're going to do 8/5. And then outside, we're going to do divided by 12. So we get, sorry, I had something typed in wrong, 7.85, something, something, something. So 7.85 years. 7.85 years. And that's our answer. So you basically find all your different parts, plug it in, and then solve for the part you're looking for. Okay, this next one says, Mandy puts $2,500 in a savings account for 5 years, compounded daily. She wants to yield $3,548. What rate should she try to get with the bank? Okay, so once again, we want to write down what we're using. So we have A equals P times 1 plus R over N to the NT. Marker's running out. Okay, so we need to find our A, our P, our R, our N, and our T. So A is the amount I want to end up with. So I want to yield 3,548. That's how much I want to end up with. So 3,548 is what I want to end up with. P is how much I started with. I started with 2,500. Okay, R is our rate, and it's asking what rate, so we know we don't know that. N is how many times it's compounded a year. It says compounded daily, and we discussed that daily is 365 times a year. And T is our time in years, so we want to know how many years. It says 5 years, so 5 is our T. So we're going to plug all this into our formula. So A is 3,548 equals P, which is 2,500, times 1 plus R, which we don't know, so we're going to put R, over N, which is 365. To the N, which is 365, times T, which is 5. Okay? So on this one, notice the R is on the inside. It's in our base. So what we want to do is first find out what this part is. Okay? So we're going to do 3,548 equals 2,500 times 1 plus R over 365 to the power of, and I'm going to do 365 times 5, which is 1825. Okay? Now I want to isolate this part like always, so I'm going to divide by 2,500. And you always want to get a fraction, so we're going to do 3,548 divided by 2,500 and hit math, enter, enter to get your fraction. So we get 887 over 625. And that equals 1 plus R over 365 to the 1825. Now, notice that R is on the inside. It's got this exponent up here. So we want to get rid of the exponent. So remember, when we get rid of that exponent, we do the flip of it. So we're going to do everything to the power of 1 over 1825. Because remember, that's 1825 over 1. So that's to the power of 1 over 1825. So those cancel, and I'm just going to leave this like it is for now. So we've got 887 over 625 to the 1 over 1825 equals 1 plus r over 365. And actually, I can go ahead and get a decimal here. So I'm going to go ahead and type that in my calculator because I'm running out of room. So we're going to type in 887 divided by 625 to the power of 1 over 1825. And you're going to get a decimal here. We're going to get 1.0002. So you're going to go until you get an actual number. So we get 1.0002. Always go at least 4 decimal places at this point. If you're in the middle of a problem, you need to go at least 4 decimal places. So then we minus 1. So that's going to give us 0.0002 equals r over 365. And then to get rid of that 365, that's r divided by. So we're going to multiply by 365. So those cancel. And r equals, we're going to take that 0.0002 times 365. And that gives us 0.073. But remember, rates are always percentages when you put them back in the word problem. So we're going to move our decimal 2 places, and we get r equals 7.3%. And that is our final answer. Okay, this next one we're talking about continuous interest now. So the first one was compound interest, and now this one is continuous interest. The difference is the formula is a little bit different. So we get A equals PE to the RT. Now E is just like pi. It's a number in your calculator. It's a number that goes on forever. So just like before, A is your final amount. It's the amount you want to end up with. P is your principal, the amount you start with. R is still your rate, and T is your time. The only difference is we don't have an N in this case. Okay, so we have if $3,000 is invested at 6% compounded continuously, that's how we know we're using continuous interest, it says continuously, then how long will it take for the investment to grow to $10,000? So, once again, it says continuously, so that tells us we're using A equals PE to the RT. So we need to find A, P, R, and T. So A is the amount we want to end up with. So we want it to grow to 10,000, so that's what we want to end up with. We started with 3,000, so that's our P. Our R is our rate. Our rate is 6%. So remember, we're going to take that percent and move the decimal 2 places. That's 0.06. That's important. The T is our time. Our time is it's asking how long. So that's what we don't know. So we're going to take this information and plug it into our formula. So we have 10,000 equals 3,000. E to the R, which is 0.06 times T, which we don't know. So once again, we want to isolate this, so we're going to divide by 3,000. Those cancel, and 10,000 divided by 3,000 is 10 over 3 equals E to the 0.06 T. Now remember that T is up in the exponent, so we want to get rid of it. So we have a base E. Remember, the opposite of base E is natural log. So what we're going to do is we're going to take the natural log of both sides. That's the ln of both sides. So we have ln of 10 over 3, you're just going to leave it, equals the ln and the e cancel, and I get 0.06 t. Now I want t by itself, so I divide by 0.06. Those cancel, and t equals, and in your calculator, you're going to type in ln, and ln is next to the 4. So ln of 10 over 3, close parentheses, divided by 0.06. And we get 20.07 if you round it. So 20.07. It's hard to see. And so it's basically about 20 years. And that's how you would do a continuous interest problem. Okay, our last one. Randy yielded $3,664.21 at an account, compounded continuously for 8 years at 2.5%. What was his principal amount? So in this case, we're just looking for, what did we start with? So it says continuously, so we're going to use A equals P e to the RT. So we need to find A, P, R, and T. A is how much we ended up with. If anytime you see yielded, that's how much we ended up with. So we ended up with 3,664.21. Then P is what we're looking for, principal amount, so we don't know that. R is our rate, it's 2.5%, so we have 2.5%. We want to turn that into a decimal, so we move our decimal 2 places, which is 0.025. And T is our time. It says 8 years, so T is 8. So we're going to take that information and plug it in. So we get 3,664.21 equals P, which we don't know, times E to the R, which is 0.025, times 8. So the first thing I want to do is I want to multiply this 0.025 times 8. So I get 0.025 times 8, which is 0.2. So I get 3,664.21 equals P e to the 0.2. Now we want P by itself, so we want to get rid of that E. So we're going to divide by e to the 0.2. Those cancel, and you get P equals, and you're just going to type that in your calculator. So you have 3,664.21 divided by E, and to get E, you hit second divide. Second divide is E to the power of 0.2. And that's 3,000.00, which is 3,000. So we started with $3,000. And that was our principal amount. Now, when doing these, if all you're missing is the A on continuous or on the other one, if the only thing you're missing is A, so it's A equals and there's a bunch of numbers, you can type in that whole thing in your calculator and that's your answer. Otherwise, you have to solve it out like these are.